So revision of the real numbers chapter. The first topic you are having Euclid's division lemma. So Euclid division lemma. What is meant by Euclid division lemma? So we are going to learn state the principle of the Euclid division lemma and calculating of the highest common factor, that is nothing but HCF of the any two positive integers by applying Euclid division lemma, and identify the certain properties of the numbers by applying Euclid division lemma. So these are the things we are going to learn. Okay. So when you go to the, suppose here one shop is there. So is it visible to you? Is it visible to you?
Yes.
Yes, sir.
Presentation is visible.
Yes, sir.
So here you see that some items are given to you here. Pencils pieces per the box. In one box 12 pencils are there, and number of boxes are 5, extra items 3. So total here, whenever total is 63. So erasers, whenever you are taking in that shop, 10 pieces are there in a box, and number of boxes 8 are there, 6 extra items are there. So total number of the erasers present 10 into 8, 80 plus 6, 86. So sharpeners, whenever you are taking 8 pieces are there in one box and 4 boxes are there, and no extra sharpeners are there. So 8 4 to 32 plus 0, 32. So like that, ball pens are also given to you here. So the ball pens are 15 are there, and number of boxes is not given to you, 0 here. Boxes are not there. So ball pens are, that is nothing but only extra loose pens are there, that is 10 here. So 63 can be written as 12 into 5 plus 3, and 86 can be written as 10 into 8 plus 6. Shortness case, if you are taking 32, can be written as 8 into 4 plus 0. And whenever you take the ball pens, these can be written as 15 into 0 plus 10, because there are no boxes are there. So like this you can express these numbers 63, 86, 32 and 10. So if you consider the number what you are taking as a B and a P. A is a number which is total, and B is the pieces per the box. So Euclid division lemma states for the two positive integers A and B, we can find the two whole numbers Q and R such that A is equals to BQ plus R. So A is equals to BQ plus R. So what you can say here? So you can say that here, whenever you are taking into consideration, you may have the A always should be greater than the B, whenever you consider. So 72, suppose if it is taken here, A is equal to 72, 12 is a 60 plus 12, and that 12 actually can be written as, so the condition is, one condition will be there in Euclid division lemma. What is that condition? There are whatever you are getting compulsorily should be greater than 0, and it should be, yes, any one of you. So here you see that this situation, Mr. Chandra has got 520 boxes of the pencils and 140 boxes of the erasers. He want to arrange them in a least number of the shelves such that each shelf has a equal number of the boxes. So solution is number of the highest common factor should be find out here. You need to find out the highest common factor of the 520 and 140 in this. So number of shelves, how many shelves you need means the highest common factor. You have the 520. So for that, Euclid division lemma can be used. So A is equals to 520 and B is equals to 140 should be taken. And 520 can be written as 140 into something. You have to divide it. 520 को 140 से divide करना है. 140 divided by, whenever you are finding division, the 100 remainder you are getting. 100 is less than the 140. It is not equals to 0. This is a procedure. 140 से less होना है ये, and here. So here, whenever you are taking next step, you have to take the 140 as a and 100 as a B. Once again, if you are dividing, 140 can be written as 100 into 1 plus 40. So now here it is not 0. Then again you have to take 100 as a and a B as a 40. So you divide the complete division you have to perform. 42 is 80, 20 remainder. Remainder, until you get the remainder, you need to perform the division. So again 20 is not a 0. Then you have to go for the, take that 40 as a and 20 as a B. So 22 is a 40, exactly 0 you got it. So 40 can be written as 20 into 2 plus 0. So then 20 is the B. That whatever you are getting here is the HCF of the two numbers 520 and 140. That means 20 shells he is taking. Then he is going to get the number of the shells 20. Each containing the 20 means 500 pencil boxes are there. So 26 boxes will be taken. So calculating the HCF of the two positive integers. So how do we calculate the HCF of the two positive integers? Now you have seen the steps is given two positive integers a and b such that a greater than b. Apply the Euclid division lemma on a and b to find the whole numbers q and r such that a is equals to bq plus r, where the condition is very much important here, 0 less than or equals to r less than b. So r remainder can be equal to 0 and it should be less than b. So if r is equal to 0, the b is itself HCF of the a and b. If r is not equal to 0, applying the Euclid division lemma to the b and r, we get continuation you have until you get r is equals to 0. You should go on dividing them. Until you get r is equals to 0, you should go on dividing them. Okay. So show that every positive integer, some different models are. Odd integer is of the form 2q plus 1. These model questions are also there in your textbook. A is any positive integer and applying Euclid division lemma, a is equals to bq plus r. So take the b is equals to 2. B is equals to 2 should be taken and we can write a is equals to 2q plus r. So by Euclid division lemma, 0 less than or equals to r less than b. So b is equals to 2, r can have the values of 0 and 1. So that means as the b value is 2, r will take the possible values what? 0 and 1. So if you take the 0, a is equals to 2q you will get. If you take the 1, a is equals to 2q plus 1 you are going to get. So a is not equal to 2q because 2q is a divisible by 2 which is not an odd number. So that's why that is a is equal to 2q is a even number. 2q plus 1 is an odd number. So every odd number will be in the form of 2q plus 1. So main key points what you have learned, let us recap here. Euclid division lemma statement, everyone have to know that statement. And we can find out the two whole numbers q and r such that a equal to bq plus r. Most of the students will say that only Euclid division lemma means a is equal to bq plus r. And condition should be compulsory, you need to mention that. So Euclid division lemma can be used to find out the highest common factor of the any two positive integers. The next topic is, in the real numbers we are having the fundamental theorem of arithmetic. Fundamental theorem of arithmetic. So fundamental theorem of arithmetic is what here? Every composite number can be expressed as, see here, 2 is a prime number, 5 is a prime number, 5 is a prime number, 5 is a prime number. So this is actually very much helpful to you. In so many applications are there with the help of the fundamental theorem of arithmetic to find out the HCF and LCM of the two composite numbers. So apply the fundamental theorem of arithmetic to calculate the prime factors and the HCF and LCM of the two composite numbers. This is very much important to you in this. Okay. So what is the statement of the fundamental theorem of arithmetic? Do anyone know? Do anyone know that? What is the statement of the fundamental theorem of arithmetic?
Every composite number can be expressed as a prime factor.
Not exactly. Every composite number can be expressed as a product of the prime numbers in a unique way, apart from the order of the prime numbers present in it. Okay, so here, whenever you are taking into consider, you see that 1950 is our number. This 1950, whenever you are taking into consider, this can be expressed as a product of the prime numbers. 1950 can be expressed as a product of the two. See, you can write as a 2 into 975. 975 is not divisible by 2, it is divisible by 5. Not even divisible by, is it divisible by any other number? It is divisible by 5, so 5 से divide कर ले तो 5 into 195. So again 195 is divisible by 5, 5 into 39. 39 is divisible by 3, 3 into 13. Now if you see that 13 is a prime number, then you can start dividing that numbers. This is actually long division method we will say. So 1950 can be written as 2 into 5 into 5 into 3 into 13. And you see that in this product, you are having only prime numbers. So this 1950 is a composite number. So this composite number can be expressed as a product of the prime numbers in a unique way. It can be expressed as a product of the prime numbers in a unique way. So fundamental theorem of arithmetic states that every composite number can be expressed as or factorized as a product of prime numbers in a unique way except the order of the prime numbers present. Suppose the same thing is, first if you divide by the 1950 in other way, first 5 is taken. Sir, I know that it is divisible by 5. So 5 into 390 I will take. Next 5 into 78. Next 2 into 39. Next 3 into 13. So last May, what do you get here? 5 into 5 into 2 into 13 into 13. Both are same only. The product means numbers are same here, but the order is different here. So the order of the prime numbers present is not very much important here. The conclusion is here that the order of the prime numbers present in this is not important. Okay? Do you understand? So every composite number can be expressed as a product of the prime numbers in a unique way except the order of the prime numbers present in that factorization. So 1950 can be written as 2 into 5 into 5 into 3 into 13 or 5 into 5. 2 5s are there and 1 2 is there, 1 3 is there and 1 13 is there. So same, but order is different here. The place is different. So when you see that, so by expressing any two numbers as their prime factors, their highest common factor and lowest common multiple can be easily calculated. So we can calculate the HCF and LCM when you express the number like this. In easiest way you can express it. Okay, so here the thing is that 1950 can be written as 2 power 1, 5 power 2, 3 power 1, 13 power 1. And like that 2010 whenever you are taking into consider is one number. And if you want to find out the LCM and HCF of these two numbers, so first here it is taken that 2010 is taken. 2010 you write the prime factorization of 2010. 2 into 1005. 5 into 201. 3 into what? 67. That 67 is a prime number. So then you have to stop it. So 2010, 2 into 5 into 3 into 67. Okay. So now here whenever you are taking this, 1950 is a one number, 2010 is another number. These two numbers, you express them 2 power 1, 2010 will be written as 2 power 1, 5 power 1, 3 power 1, 67 to the power of 1. Now, first in a means prime numbers, smallest prime number is taken first 2, next to prime number 3, next to 5. Order is changed here. Now, if you want to find out the HCF and LCM using the HCF and LCM of the 1950 and 2010, it's an easy task to use. The common numbers present in this what here? 2 is a common, 3 is a common, 5 is a common. 13 is not there in both. 67 is not there in both. So common prime numbers presented 2, 3, 5. And in this, you have to select here whenever you are going for most of the students will get confused. HCF of the any two numbers means highest common factor will be the smallest number normally. So the smallest powers should be taken into consideration in the common. So what HCF is nothing but what are the prime numbers common are there in that the smallest powers. 2 power 1 is present in both, so 2 power 1. 3 power 1 is present in both, so 3 power 1. 5 power 1 is there here, 5 power 2 is there, so 5 power 1 should be taken. And 13 should not be taken. So HCF, whenever you are finding, only common should be taken into consideration. And whenever you find the LCM, the highest power of the prime numbers, highest power of the prime numbers means both दोनों में 2 power 1 है, that is only the highest. दोनों में 3 power 1 है, that is only the highest, 3 power 1. And दोनों में 5 power 2 है, and 13 is not present in both, but also should be taken into consideration. 13 power 1. 13 power 1 and 67 to the power of 1. These two also should be taken into consider when you are finding the LCM of these two numbers. If you are finding the LCM of the two numbers, then you have to find out these things. Okay? So this is LCM. LCM whenever you are finding, not what are the prime numbers are there, all the prime numbers should be taken into consideration. And the highest power of the prime numbers. But HCF whenever you are taking, only the common prime numbers in both. So and that product whenever you are taking into consider HCF and LCM. So product of the two numbers will be equals to the product of the LCM and HCF. You observe that any two numbers, not only 1950 and 2010, any two numbers product you take, LCM product and HCF means product of LCM of the two numbers and HCF of the two numbers will be equal to the two numbers. Only this is possible for the two numbers only. 3 numbers and 4 numbers it is not applicable. Okay? Only for the two numbers. 3 numbers whenever you are taking it is not applicable. For the 3 numbers what is there, you can refer your textbook last mein de diya hai, chapter ending. Because if I say that you will be forgetting and you refer and you try to, it is not that much important to you for the examination point of view. So fundamental theorem of arithmetic kya hai? Any one of you please read that. Any one of you please read that statement of the fundamental theorem of arithmetic. Shalu.
Yes, sir. Every composite number can be expressed as a product of prime, and this factorization is unique apart from the order in which the prime factor occurs.
Very good, thank you. So this is HCF is nothing but product of the terms containing the least powers of the common prime factors, and LCM is nothing but is equal to the product of the terms containing the greatest powers of the prime factors of the two numbers. All the prime factors, not common. Please do remember that. See here, LCM. So before going to the next topic, I am going to explain. LCM, least common multiple. Multiple बोले तो multiples क्या है? बड़ा numbers होता है, given numbers से. So बड़ा number बोले तो all should be included. Like that you can keep in your mind. Multiples are always greater than the given numbers. Suppose 1950 is the given digit. इसका multiple इससे ज़्यादा बड़ा होता है. So that's why big number होता है. But sir, most of the students will get confused that least common multiple है ना. So least बोले तो smallest power should be taken. No, not like that. Greatest power should be taken. Because multiples now, that is, in that multiples, least one we are taking into consider. Least common. Highest common factor. Factors are always smaller than the given numbers. Smaller or equal. Suppose 8 factors if you are finding. So what do you get? 1, 2, 4 and 8. These are all less than or equals to 8. These are all less than or equals to 8. So that's why you can take into consider here. This idea means this strategy can be applicable here. You can apply that. So now the next thing is that revisiting the rational and irrational numbers. The concept of the rational and irrational numbers. See here, some numbers are crossing the line here, and while they are crossing the line, it is glowing the one. Rational numbers blue light se hai, irrational numbers Q. So here we are going to verify that rational numbers, distinguish between the rational and irrational numbers, and prove the theorems related to the rational and irrational numbers. We can prove that the main important thing is that prove root 2 is an irrational number, prove root 3 is an irrational number, prove 2 plus root 3 is an irrational number. So rational numbers club. See, there is a rational numbers club is there. Means here it is given to you to classify the numbers as a rational and irrational numbers. Here some numbers are shown to you. In this, you do not belong to the irrational numbers. These are in which we insist they are the rational numbers. So here thing is that if one situation is taken into consider that 2 plus root 3 is 1. So they are all saying that we are all the rational numbers. See that. But are the rational numbers 2 plus root 3 and root 3 and root 2?
No, sir.
So here in a court they are solving the, just like one situation is given to you to make you attract here this one, the case of the rational numbers and irrational numbers. So whenever you are taking a number is called a rational number if it can be written in the form of the p by q, where p and q are integers and q not equals to 0. Please note this point very much clearly. So these numbers whenever you are taking into consider, these cannot be written in the form of the p by q. Irrational number means which cannot be written in the form of the p by q, where p and q are integers and q not equals to 0. So we are the irrational numbers. We insist that we are the rational numbers. They are saying that again we are rational numbers only. We see that let's be smart argument with that. So if a prime number p divides the q square, there is a one theorem here, and then p also divides the q. P divides the q square means p divides the q also. So that is a here main theorem here. One theorem is the proof of the theorem. If you see that, let the prime factorization of the q as a p1, p2, pn. Actually, this theorem is not that much important to you for the examination point of view. Main thing is that in the examination point of view, you are going to have the root 2, proving your root 2 or root 3 or root 5 or 2 plus root 3 as an irrational numbers. So that means in a contradictory way we have to prove it. Although they are not rational numbers, we have to consider as a rational numbers, and we get one contradiction based on this theorem. So that's why this theorem is given to you. So what is the theorem says to you? Q is a one number if you are taking into consider, the prime factorization is given to you. And q square is also the prime factorization p1 square, p2 square and so on, pn square. Given that prime number p divides with q square. So by the fundamental theorem of arithmetic, q square has a set of the unique factors. So once you, let me explain to you once again, we'll go back. So you see that here, q square has a set of the unique factors from the p1. p1 to pn से एक number p होगा. In the numbers, prime numbers from p1 to pn, one number p compulsory should be there because p divides q square is given to you. So p is the one of the prime factors of the p1 to pn. So that, but p also a factor of q. So that is because Q is equals to P1, P2, P, Pn. Therefore, we can say that P divides the Q square and P divides the Q. So, what is Mr. Public Prosecutor is trying to prove here? I still believe I am a rational number. They are arguing that we are the rational numbers only. Okay, I accept you. You claim you are meet and just one condition. So the lawyer said that assuming root 2 as a rational number, there must be a two numbers P and Q such that we consider that it is rational numbers. Okay, you are all accepting that root 2 is also there. Root 2 is also there in that. So root 2 बोल रहे हैं मैं rational number हूँ. नहीं rational number नहीं है. आप irrational number बोल के public prosecutor is saying, and he is proving that. Okay, we will consider that you are the rational number. That means root 2 can be written as P by Q. And P and Q have the common factor R. If they are having any common factor R which is not equals to 1, and with that common factor it is divided. So that they can be expressed as a co-primes. A by B form में express कर लिया है, where A and B are the co-primes. Co-primes is nothing but they don't have any common factor. So both squaring on both sides, what do we get here? 2 is equal to A square by B square. We will get 2B square is equals to A square. That means 2 divides the A square. Because 2 divides here 2B square. 2B square का divide करते हैं ना? ये 2B square को divide करते हैं. So that means 2 divides A square. So we have 2 divides A square, then 2 should divide A also. Thus A can be written as 2 into C sum. And where C is another integer. And putting A equal to 2C in this equation, we are going to get it 2 divides B square also. 2, because B square is equal to 2C square, you got it. So 2 divides B square. So by the earlier theorem, we can say that 2 also divides the P. So 2 divides the both A and B. But first starting में क्या बोला है? A and B are co-primes. Contradict is nothing but. So contradiction we are getting. Sorry, ठीक है. आप irrationals बोल नहीं rationals बोल रहे. Rational numbers consider कर दे तो वो last में fail हो गए. So that's why this contradiction is arising because we have assumption taken that root 2 is as a rational number. Root 2 को rational number consider कर लिया. उसके वजह से हमको last में conclusion गलत आया है. So that this proves that root 2 is an irrational number. So like that, the public prosecutor proved that. And here root 3 is also asking. I am also same way. Root 3 कैसे है वैसे prove करना है. Root 3 को भी. I am also a rational number बोलकर root 3 बोल रहे हैं. So that means he in the same way root 3 is taken as it is taken previously, same way. And now here the 2 plus root 3 is asking. This is a way to this. These are the very important questions to you even in the examination also. Exam point of view में ये questions ज़्यादा important है. So please practice well because if it is explained to you like this one situation, आपको बहुत ज़्यादा याद रहेगा. So that's why this is taken into consider. Okay. So assuming 2 plus root 3 is a rational number, there must be 2 co-primes such that A and B. So here A minus 2B by B is a rational number since A and B are the two integers. But already we have proved that root 3 is a rational root 3. So we have root 3 minus A minus 2B by B and A minus 2B by rational numbers. Thus root 3 is a rational number, but this is contradiction to root 3. Already we have proved irrational numbers. So please concentrate on this proof. This is very important here. These proofs are very important here. So this contradiction has arisen because the first assumption that 2 plus root 3 rational number consider कर लिया है. So that's why it is incorrect. So therefore it says that this is enough here. It is not essential to you to prove. Again, root 3 is a rational number. This question will be given to you for the 2 marks whenever it is taken. Okay? Did you understand? समझ में आया ना?
Yes, sir.
Yes. Now here you see that like this we have proved that the case is solved here, irrational numbers and rational numbers. So that means whenever you take that, a number can be written in the form of the A by B. Conclusion is given by the judge. Judge conclusion दे दिया है. A by B where A and B are the integers and B not equal to 0 are called irrational numbers. If it is not, it cannot be written. The sum of difference and product of quotient of the rational and irrational number is also a rational number. साइन करके केस को सॉल्व कर दिया है. Okay. So now here we told you that you are different from us. Yes, now we agree that you are rational numbers and we are also not like you. They said that rational numbers, and Mr. Public Service Prosecutor, can you settle this debate? Okay. So with the help of the permission of the my lord, here it is he is saying that with your permission, my lord, this time I have to agree with the irrational numbers. Rational numbers are of two different kinds. Rational numbers are of two different kinds. Okay. So rational numbers are of two different kinds. What are the two different types? Let me prove that my point with a few examples of the rational numbers. Suppose rational numbers, whenever you are taking into consider 3 by 8, 5 by 3, 16 by 25, 7 by 11. 3 by 8 decimal form में express कर लिया तो terminate होगा है. And 5 by 3, if you take that, it not terminates but recurring है, repeated आते हैं 5 by 3. So 1.666. The decimal form of the rational number is 16 by 25 terminates. So देखो ये terminate हो रहा है. So here 7 by 11, if you are taking it, it is non-terminating and recurring. It is non-terminating and recurring. So like this, there are two kinds of the numbers. So what are the two kinds of the numbers here? What are the two different kinds of the numbers here? One is terminating decimal, another one is non-terminating recurring decimals in the rational numbers. To show there is, let me show with the help of the few more examples. Here are the few some rational numbers whose decimal expansions terminates. ये सारा देखो 3 by 8 वो terminate हो रहा है. तो do you notice the pattern of the we express these rational numbers in a decimal form? देखो denominator में क्या है? 2 है, 5 है. Other than this, nothing is there. In the denominators, you are having only 2 and 5. Okay, so this brings us to an important theorem that P by Q is a rational number such that the prime factorization of the Q is in the form of the 2 power A, 5 power B, where A and B are positive integers. Then the decimal expansion of the terminates. Decimal expansion of that rational number terminates होता है. Denominator में 2, 5. When you express in a simplest form, that means you don't get confused that if you are having in the denominator 3 and numerator also 3 is there, both will be cancelled. That point should not be taken into consideration when you express them in a simplest form. So see here 0.35 decimal number, terminating decimal, इसको 35 by 100 लिखा है, and last में 2 power 2, 5 power 1 you are getting. So only 2 or 5 or both you are getting in the denominator. 18.75 if you take 75 by 2 square you are getting. So that means another important theorem that if you are having denominator, see here, it can be written in the form of the P by Q, where P and Q are the co-primes, and prime factorization of the Q is in the form of 2 power A and 5 power B, where A and B are the positive integers. Where A and B are the positive integers. Okay. So here we can come to the one conclusion that rational numbers decimal expansion does not terminate. Identify ourselves. We can identify them. So what is that? Denominator Q not in the form of 2 power A and 5 power B, where A and B are the positive integer. Then the decimal expansion of the rational numbers P by Q does not terminate and it is recurring. It does not terminate and it recurring. Did you get my point here? So you are different from the rational numbers? Yes, we do. They are all non-terminating, non-recurring decimals. Irrational numbers are what? So now here the judge asked that rational numbers and irrational numbers are two separate groups. Rational numbers are terminating decimals, are non-terminating recurring decimals. Irrational numbers are non-terminating, non-recurring decimals. In decimal form, whenever you are taking into consider, they are non-terminating, non-recurring decimals. Okay, so here these, with the help of that, you can say. So now let us have a real numbers club. Real numbers is nothing but all rationals and irrationals together. If you take into consider rationals and irrationals together, if you take into consider, then it is a real numbers. So the key points in this rational numbers and irrational numbers chapter, whenever you are taking it, a number is called a rational number if it is in the form of the a by b or p by q, where a and b are integers and b not equal to 0. P by q also you can say, doesn't matter. A number is called irrational number if it cannot be written in the form of the p by q or a by b. So first starting में p by q बोला है, a by b भी बोल सकते हैं. So the sum and difference of the quotient and the rational numbers is also a rational number. Sum, difference, product and quotient of the rational numbers is also a rational number. Rational numbers are two types of them depending upon the whether they are decimal form or terminating recurring. If a rational number is terminating decimal, it can be written in the form of the p by q, where p and q are the co-primes. And q is in the form of 2 power a, 5 power b, where a and b are positive integers. Terminating होता है. Denominator 2 power a, 5 power b में होता है तो terminating. If it is not in that, it is non-terminating, non-recurring. Non-terminating, recurring, repeated होता है number. If denominator, so by observation itself, you can say that it is rational number only, but it is non-terminating, recurring decimal. Okay, see here. Converse, p by q rational number such that prime factorization is in this form. Then it is the decimal expansion of that does not terminate and it is recurring. It does not terminate and it is recurring. Okay. So these are the main points here you have to remember. And here, not only don't consider that denominator में आप ज़्यादा लोग confuse किधर होता है ना. Suppose in the I have given one number to you 3 by 2 into 3 into 5. So ज़्यादा लोग ये terminating और non-terminating recurring I am asking 2 by 2 sorry 3 by 2 into 3 into 5. Suppose here I am giving to you one final conclusion here. 3 by 2 into 3 into 5 I have given to you. So whether it is terminating or non-terminating recurring. Whether it is terminating or non-terminating recurring. Can anyone say?
Non-terminating recurring.
Non-terminating recurring. गलत है. ये terminating because you are saying that the denominator में 3 है ना, but it is not in the simplest form है ना. ये दोनों cancel कर रहे हैं. Simplest form में express करना है. So now final answer is this is actually what I given to you. You know, it is 1 by 10. I gave to you 1 by 10. 1 by 10 is nothing but 0.1. मैं 1 by 10 को different way में लिख दिया. तो 0.1 है वो. समझ में आया? So simplest form में लिखने के बाद denominator check करना है. Your idea is okay. You are getting confused. The denominator 3 है ना, that's why it is non-terminating recurring बोल रहे हैं. No, that's not correct. That's not at all correct. Okay? Simplest form में लिखना है. समझ में आया अभी?
Yes, sir.
Still, if you have any doubt in this chapter, you can ask. Okay?